Hello everyone, welcome to Basic Chemistry. Today we'll be looking at a few topics including states of matter, changes of state, and so on. Now, I would like to welcome everyone, including those who will be watching on YouTube. Let's begin. States of matter is the first one we'll be covering. Alright, what is matter? Matter is simply anything that takes up space and has mass. That is very important to note. Mass is anything that takes up space and has mass. Simple, right? Okay. Now, according to that definition, which of the following is matter? Here we have a volleyball, right? Yes, that is matter. And we have a pretty birthday cake, and that is also matter. Why? Because they both take up space and they both have mass. There are three states of matter. States of matter are simply the distinct forms in which matter can exist. Now, let's see what I mean by that. So here we have these three different states. I'm going to give you a moment to figure out for yourselves what you think you will call each of one of these. So what would you call this? Would you call it a block, right? And you'd be like, maybe that's a drop of water and that's a cloud. Now these are here to represent the three states of matter. This right here is a solid. This is a liquid. And lastly, this is a gas. So these are what we are going to be calling the three states of matter: solid, liquid, and gas. Now let's focus on the changes of state. Now, when we talk about the changes of state, we are only going to be referring to the changes of the three states of matter. Everything is going to make sense. It's all going to connect. Alright, now what is that? Change of state of matter is referring to the physical changes that can be seen in matter. Alright, don't panic. Let's see how it works. Remember, we have these to represent our three states of matter: the solid, the gas, and the liquid. So if you look at these arrows, you would see that they're pointing in both directions, which suggests that the changes, the physical changes, are reversible. Each and every one of them are reversible. Okay, so if we wanted to change something from a liquid state right here to a solid state, we would say that that is freezing. So you put water in your ice trays and you put it in the freezer. That is what we call freezing. Now, if you changed it back from ice to a liquid, you would say that you melted it, right? Now, for a liquid to a gas is called evaporation, and from a gas to a liquid is called condensation. All right? And this reaction here, this change here is reversible, and it's the same thing. So if they're solid, like those mothballs, if you know what a mothball is, you will see that when you place them somewhere, after a few days you will see it reducing in size. That is what we refer to as sublimation. And from a gas to a solid is also sublimation. Let's look at physical changes versus chemical changes. Notice states of matter that we just observed went through physical changes. The melting, the freezing, the sublimation, they were all physical changes. But now we are going to be looking at the physical changes and chemical changes. Now, what are physical changes? These are alterations that occur in matter which do not affect the chemical composition of matter. The shape and the size of a matter can be changed. So if you take a piece of paper and you ball it up, that's a physical change. You realize the paper is not flat and straight anymore, it's changed, but it's still paper. Do we understand? If you remove, let's see. Okay, let's look at some examples and maybe this will make a little bit more sense. Right, so if we have the folding of paper, it's still paper after you folded it. That's a physical change, right? If you bite chocolate, what is in your mouth is also chocolate. So that's also a physical change. When you crack an egg, the two pieces of eggshells are still eggshells. And lastly, when you melt ice, at the end of the day, it's still water. It's the same compound. Is water that's frozen and is water in the liquid state. These are examples of physical changes. Now let's understand what a chemical change is, and this is simply a new substance is formed by means of a chemical reaction. Do we understand that? A new substance, a completely new substance, is formed by means of a chemical reaction. And the chemical reaction is usually irreversible, please note that, and involves the rearrangement of atoms in one or more substances. I'm sorry for that spelling, guys. We are going to ignore that. Let's pretend I spelled that correctly. Alright, some examples of chemical changes involve digestion. We all know that there are all these chemicals in our stomachs that break down the food, and in doing so, chemical reactions occur, and those are chemical changes, because when they go into your stomach and they go through all these changes, it's not going to be the same piece of chocolate that you bit off. Do we understand? Photosynthesis. This is also an example of a chemical change, and here we have a chemical reaction to represent this change. So most of the time when a chemical reaction occurs and there's a chemical change, you should be able to represent this change with a chemical equation. Combustion is an example, and soap detergent reaction is another example of chemical change. Next topic, element. This is one of the most basic things that we need to understand going through chemistry third formers. This is what we need to understand what an element is. Do you not know what an element is? Okay, I will tell you. An element is a pure substance that cannot be chemically broken down any further. It cannot. It's that simple. You just can't make it any smaller. Each element is made up of one type of atom. Only one. And what is an atom, you might ask? An atom is the basic building block for all matter and is the particle that defines each element uniquely. Do we understand? Atom is the most basic unit that we have to represent in chemistry. Okay? The periodic table. I'm pretty sure some of you might know what the periodic table is. We've all seen one, we might have heard about it. You probably went to school and was like, oh yeah, what's that on the wall, chemistry teacher? Yes, that is the periodic table. And if you don't know, the periodic table is a table of chemical elements arranged in order of atomic number. And the atomic number is the number of protons found in the atom. And these protons are usually in the nucleus of the atom. The nucleus is found in the center of the atom and it's made up of protons and neutrons. So when you arrange them, you will see 1, 2, 3, 4 at the top of each of the elements, and those were what we would call the atomic number. Okay? Here is what the periodic table looks like. It is beautiful. Look at this. All these letters, don't get confused. What you would need to do is take the time to learn some of these. Maybe the first 18 or the first 20, I would advise you to learn at this stage so that when you see HE, you're not going to be like, he? Huh? What is that? Or you see O like, what is that? You would know that Be right here is beryllium, or you would know Mg is magnesium. So it is important to familiarize yourself with at least the first 20 elements of the periodic table. And as you can see here, they're arranged 1, 2, 3, 4. That is what I was talking about, the atomic number. Alright? It's in order. It's very simple. Don't panic. So here what is circled, we will call these the metal. These are metals. Right here is what we would refer to as the transition metals. And over here would be non-metals. Alright? And hydrogen is also a non-metal. Don't mind hydrogen is on that side. It is also a non-metal. But let's move on. Oh, metals and non-metals. What are we thinking here? Okay. Metals, physical properties. Now these, I know everyone would know what a metal is. When you know the wires inside of um the little wires inside of your electrical components, that is a metal. It's usually copper. That is a metal. I'm pretty sure we've all seen galvanized. We've all seen, you know, aluminium. That's a metal. Some of y'all be like, it's not aluminium, it's aluminum. It's aluminum. Okay, fine. It's aluminum. So let's look at these properties so that we'll be able to identify metals when in the laboratory, or if we just look at something, we should be able to identify a metal. Okay, so one physical property is high melting point, and all this means is that very high temperatures are needed to change the metals from a solid state to a liquid state. So in order to, in quote, melt the metal, remember we went through this, melt the metal, you're going to have to get those temperatures up really high. And I'm not talking about 400 degrees, I'm not talking about 2 degrees, I'm talking about some high temperatures. Okay, great thermal conductors, another physical property. Metals are very good at conducting heat, as it does not take long for heat to pass through them. Another physical property is that metals are good conductors of electricity. Due to the free electrons in metals, oh my goodness, guys, we're just gonna ignore the spellings that I have here. But due to the free electrons in metals, electricity is what I meant to say here, is easily passed through the metal. Do you understand? High density is another physical property, and metals have ions which are closely packed together due to the strong forces of attraction between them. And the last two are they're malleable and ductile. This means that in the case of being malleable, they can be bent and shaped without breaking because of how the atoms are in layers that allow them to slide over each other so they don't break. Ductile, suggesting that they can be hammered very thinly or formed into the copper wires I was talking about earlier without being broken. Now let's look at the physical properties of non-metals. Here we have their insulators. All this means is that they don't allow electricity to easily pass through them. So if you try to pass electricity through your eraser, it is not going to work because you don't have free electrons floating around in that eraser. Do you understand? They're poor conductors of heat. They do not have free electrons, like I just said, that transfer the heat. Alright? They are brittle. Non-metals can easily be broken with energy when energy is applied. So some non-metals, you would realize that if you apply energy to them, they would turn to powder. And they're dull. They don't shine like metals. You know, you see the metal, it glows, it shines, the light reflects nicely. For non-metals, that is not the case. And lastly, they have low melting points. So we spoke about the high melting points of metals, but in non-metals, they don't require high temperatures to be changed from a solid to a liquid. Let's look at compounds. Compounds are made up of two or more elements chemically joined together to form a new substance. Remember we spoke about elements earlier, and elements are they can't be broken down. But compounds can be broken down into the two or more elements. Do we understand? Atoms can be brought together to form molecules. So remember we were saying that there are atoms that are unique to each element. So when you bring these atoms together, they will form a molecule. Let's make a little bit more sense of this. So here we have we would say that this is a hydrogen atom, and this is our hydrogen atom part 2, and this is our oxygen atom. Now usually when you have an oxygen, you would say it's diatomic, but that's not for this stage. So when this come together, these are all, this is hydrogen element, oxygen element, but these are all atoms, right? When we bring them together, we get H2O, because we have the 2 hydrogen and 1 oxygen forming H2O, and this is our molecule, this is our compound, right? So that is what a compound is. When you bring elements together and you form a new molecule, you form something new, a new substance, that is what we refer to as a compound. Mixtures. What is a mixture? Mixtures are when 2 or more substances which are not joined together chemically of come together and form a new substance. So let's say you put sugar in water. All you have to do to mix them is stir it, correct? Yes. So they're not joined together chemically. That's the slight difference between a compound and a mixture. So a mixture can be made up of compounds coming together and being stirred together, water and sugar, 2 different compounds coming together to make a sugar water, right? But they aren't brought together chemically. There's no exact chemical reaction going on to represent that being made. Let me know if I didn't explain that properly. Mixtures can be homogeneous or homogeneous, or heterogeneous or heterogeneous. Homogeneous versus heterogeneous. So for homogeneous mixtures, you would see that they have uniform composition. You would see that the particles are evenly spread out within the other substance. So you would usually have a solvent and a solute, and the solute is usually evenly spread out through the solvent. Alright? For heterogeneous, they have a varying composition. For homogeneous, the component cannot easily be seen with the naked eye. And what I mean by that is when you completely stir that sugar in the water, unless there was too much sugar for the water, you're not going to be able to separate the sugar from the water by just looking at it. You won't be like, it would probably just be a brown liquid, right? For heterogeneous though, you can easily see the components with the naked eye. So when you put mud in water, it's not going to dissolve in it. So you'll be able to see, okay, there's the water and there's the mud settled. Do you understand? And lastly, we would see for a homogeneous mixture, the compounds cannot be easily separated. And for heterogeneous, the compounds can easily be separated. Now, when I say easily separated, they can be separated. Now, if you back to the sugar and water, you can't just pour out the water from the sugar anymore because it's already dissolved, right? But there are a few processes that these things can undergo to regain the anhydrous sugar or the dried out sugar. Okay? The heterogeneous mixture, they can be easily separated. So you just strain the mud from the water out of the mud, and you will have the mud and the water separated again. So example of homogeneous would be air. You can't see the difference between the oxygen and the carbon dioxide in the air. It's just there. And steel. A heterogeneous mixture, mud in water, and milk because it's a colloid. Alright? Now, we went through the whole set of definitions and explanations and examples. So, we're going to do a little exercise. So, I want you to look here and state which of the following would you consider to be an element, a compound, or a mixture. So, just take a few minutes, write it down, put it in your head, have it ready because I'm going to show you the answers in 1 second. Okay? Let's give you 5 seconds. Okay. So the first one, we have hydrogen. And I know that I've shown this to be, I'm so sorry guys. I've shown this to be an element. Alright? Clearly, it's an element. We went through this. We've created water. In the previous slide, it's an element. This carbon dioxide is a compound. Why? Because you can see we have carbon and you have two oxygen, two elements. These elements came together to form a compound. Salt water, that now is a mixture. Alright? And lastly, lithium, that's an element. Mixed states. Solid liquid mixtures. Let's discuss soluble substances. I have this backwards. I think we should talk about solution. So right here is what a solution is. It involves a solvent, and the solvent is what does the dissolving. So for example, between salt and water, what do you think would be the solvent? The solvent would be the water. And a solute is what is being dissolved. Alright? Now, there's a difference between soluble substances and insoluble substances. A soluble substance, I'm sorry, is a substance that dissolves in water. Insoluble means that it doesn't dissolve in water. Simple. The mud, it doesn't dissolve in water. But sugar is soluble. It dissolves in water. Are we clear? The reason I'm using the same example is so that we can always relate back to an idea, because that's something that now you should be able to relate to from the first time I used that example. Okay? Solid liquid mixtures, again, we have a suspension. A suspension is when the particles of this mixture do not dissolve, but rather are left to float around, like salt, like chalk and water. So if you try to mix chalk and water, it's just going to be floating around, but it's not going to dissolve. If you want to try it, please go and try it, because it's important that you see these things live. If not, you can look for videos on YouTube to help you. Liquid mixtures. So liquid mixtures will use the terms miscible and immiscible. What does miscible mean? This is when a liquid is able to dissolve in another liquid to form a homogeneous mixture. Immiscible though, meaning it does not want to mix, is when the liquid does not want to mix. It doesn't really dissolve in another liquid. So we have oil and water, and as you can see here, you will see like these little bubbles being formed on the surface of the water, because it's not going to dissolve. No matter how much you stir it, you're always going to get these little grease circles at the top, because the oil is not going to dissolve no matter what you do. Just is not. You could try it. Let's look at solid mixtures. And we're just going to look at alloys. And alloys, or when you mix metals. So to form brass, you would mix copper with zinc. Okay? Now, that is the end of basic chemistry. I just wanted to introduce everybody to what chemistry is, what is going to be repeated throughout chemistry at any level. These are things you're going to constantly be seeing. You're going to have to familiarize yourself with these things to fully understand chemistry. Thank you for watching this video or joining, and hopefully I'll see you in basic chemistry number 2, where we'll be looking at separation techniques.